This lesson is for 6-8 dilations. You've already used transformations such as translations and reflections in the coordinate plane. So today we're going to look at graphing dilations on a coordinate plane and finding the scale factors of dilations. So a couple terms that we need to be familiar with. First of all, dilation, of course. A transformation that enlarges, or reduces. I do not like that pen. Let's try that again. Reduces, that's better, a figure by a scale factor. And then if the center of the dilation is the origin on a coordinate plane, we use the notation xy becomes kx and ky. So for instance, if you had a point on a coordinate plane and it was 3, 5, okay, and the scale factor, let's say we had a scale factor of 1/2. Well, then our notation for that scale factor to figure out where the dilation would go would be, so scale factor, this is k, so k equals 1/2. So the scale factor would be 1/2 times 3, and then we use scale factor again, k, 1/2 times 5. So now when we have a figure on the coordinate plane, and let's say that we want to use a scale factor for this triangle, so we're going to say that the scale factor is 2. So what that means is now we're going to take each of those ordered pairs and we're going to multiply the scale factor by each of the coordinates, each part of the ordered pair. So for A, it would be 2 times 1, 2 times 1. For B, we would do 2 times 1 and 2 times -1. And then finally for C, we would do 2 times 2 and 2 times -1. So our new image, our final image, what we do is, in order to signify that it's another, the dilation, or a copy of the other one in terms of a dilation, we use tick marks to show that it's the new image. So we say A prime, and we put the new coordinates. So the new coordinates for A prime would be 2, 2. The new coordinates for B prime would be 2, -2. And the new coordinates for C prime would be 4, -2. And so now if we graph that, so A is 2, 2. That's going to be here. This is A prime. And then we graph B, so 2, -2. So that's going to end up here. That's B prime. And then C prime is 4, -2. That's going to be here, C prime. And so we just connect those points, and we have our dilated shape. Now the other thing you want to notice is this is a scale factor of 2. Alright, so we're going to come back to that, but this is a scale factor, so this scale factor for this problem is more than 1. So if we have an example like this where we have a polygon or some shape, so this is triangle XYZ, and we have the coordinates. Now if we know the scale factor is 1/2, so then we do the same thing. We take each of the parts of the coordinate, so we multiply by 1/2. So 0 times 1/2 and 6 times 1/2. And then we have 4 times 1/2 and -4 times 1/2. And then finally we have -4 times 1/2 and -2 times 1/2. Okay, so our new shape, All right, our new shape, let's go ahead and give it a different color. Let's go with green. So if we go to our new shape, then, so our new shape, we would end up with, so for x prime, it would be 0, 3. So 0, 3, this is going to be x prime. And then for y prime, we would end up with 2, negative 2, which would be here. This is y prime. And then for z prime, we would end up with negative 2, negative 1. So negative 2, negative 1, so it's going to end up here, z prime. So that is our new shape, or our new figure, our dilation, right? So now our scale factor was 1/2. So that leads us to this idea about how we can think about scale factor and knowing what kind of a shape we're going to end up with. So if the scale factor is greater than 1, then the dilation is an enlargement. If the scale factor is less than 1, then the dilation is a reduction. And so if we're looking at the scale factor or trying to figure out the scale factor, there are a couple different ways we can go about this. If we want to look at the lengths of each of the sides and how figure out how those change, or if we want to look at how the points change, either way will give us the same answer, okay? So if we look at the lengths of, let's say, A to B, so A to B, so I need A, and we already have there. Then if I get B, the coordinates for B are going to be 4, 4, and the coordinates for B prime are going to be 2, 2. So if we focus on the x coordinates for these two to figure out how much these or how far these change, so we're going to look at, and the way that I remember it is I go copy over original. Okay, so if we look at the lengths and the scale factor for the lengths, then we could do the scale factor is the copy, so that's the A prime and the B prime. So if we look at the x coordinates, we're going to start with B, and we're going to go 2 minus 1. And then for the original, we start with B, so it would be 4 minus 2. And so our scale factor would be 1 over 2. Now that makes sense because it's less than 1, so therefore we have a scale factor that we have the new drawing, which is smaller. So that would make sense. The scale factor is 1/2. Now the other thing we can do is if we just look at the points, I mean if you look at A and you look at A prime, we have a 2 and then a 1, and then we also have 4 and a 2. So even if we don't do the whole, you don't have to do the whole side. You could also just look at the points and figure out comparing those, and you will get the same thing. So those are the different ways we deal with dilations. Hope it helps. Do the math.